So today we start trigonometric functions. We will define trigonometric functions. So these are the 6 trigonometric functions: sine, cos, tan, cot, cosec, and sec. These are the 6 trigonometric functions which you know. Earlier in 10th standard, or probably you might have studied even in 9th standard, in both the standard, you have defined trigonometric functions with the help of right angle triangle. Here the approach is with the help of unit circle. So I'll consider first unit circle. Now what is a unit circle? That is a circle. We take a circle with center at origin, that is 0 0, and radius equals to 1. So we have started with a circle with center at origin and radius equals to 1. Such a circle is called unit circle. And equation of such a circle, you will learn later on how to get the equation. Right now I'm stating the equation, which is x square plus y square equals to 1. This is the equation of the unit circle. Okay, so this is the unit circle. X-axis, here there is a y-axis. We consider one unit circle. So this is a circle with center at origin and radius equals to 1 unit. So this is a center which is 0 0, and this is the radius which is 1 unit. This is 1 unit. So coordinates of this point will be, if this is 1 unit, 1 comma 0. On the x-axis, y coordinate is 0. If I call this as b, on y-axis the x coordinate is 0, and this is 1 unit, so 0 comma 1. If you come to this, here let me call this as a dash, for example. Now this is 1 unit, but it is on the left side, so minus 1 comma 0. And let me call this as b dash, for example. On the y-axis, first coordinate is 0, and here you have 0 comma minus 1. This much we know. Now if I take this as arc length x, this arc length x, for example, if I call this as point P, then this arc AP makes an angle x radian. You know this much. This is x radian, which we have studied. Then now this is a point on the unit circle, and it is in the Cartesian plane. So this point will have 2 coordinates. You know, every point in the Cartesian plane would have how many coordinates? 2 coordinates, x and y. So here the first coordinate, that is known as the cos function, and the second coordinate is known as the sine function. So I'll define in this way. For example, cosine is a function from real numbers to real numbers. We are defining in terms of functions now, remember. And cos x. So this is like a variable, this arc length. If you remember, in functions you used to write f of x. In functions, we used to write f of x. So here x is this x, and instead of f, you have cos, equals to x coordinate of the point P on the unit circle, as shown in the diagram. So what is cos? That's the x coordinate of the point on the unit circle. Now the second coordinate here, which is known as y coordinate, which is sine functions, is a function from r to r, real numbers to real numbers, and sine x. So sine is like f, as I explained here. It's like this f, and x is this x. It is given by y coordinate of the point P on the unit circle, right? So now this way we have definition of cos and sine function. The first coordinate, if this arc length is x, then the first coordinate is called the cos function, and if this arc length is x, then second coordinate is called the sine function. So here everywhere the first coordinate represent the value of the cos function and the second coordinate represent the value of the sine function, right? So cos function, I repeat here, cos function is the function from R to R. And how do we define cos x? X coordinate of the point P. Sine function is the function from R to R. How do we define it? It is a y coordinate of the point P on the unit circle. Here in this discussion, remember this unit circle play a very important role in the trigonometric functions. You will see effectively we'll use the concept of the unit circle in the discussion of trigonometric functions in the later part of this chapter. Now at this place arc length is 0, because this is a starting ray, initial ray will be same. So here arc length is 0. So here you can say that x is 0. You know this. Here arc length I have taken x unit. If I move further, if I go up to this much, first quadrant only, if I take one complete revolution, for example, arc length is 2 pi, that we did in earlier session. If I take up to this, then the arc length is pi, this much. So here you can say that x is pi, arc length here, this much. If I go up to this, then the arc length is pi by 2 radian, right? That means this angle, which is pi by 2 radian as well as 90 degree. This angle is pi radian, that is same as 180 degree. Now if I take this much, then now this will be arc length equals to 3 pi by 2. And if I complete one revolution, then now arc length become 2 pi. So beginning was 0, now it becomes 2 pi. And I was moving in which direction? Anti-clockwise, remember. There the arc length is taken as positive number. If I continue further in the second round, here it was 2 pi. Now if I continue at this plate, 2 pi plus this much arc length. This arc length is how much? Pi by 2. So 2 pi plus pi by 2, it becomes 5 pi by 2. During the second round, remember. During the first round, it was pi by 2. If you complete one revolution around the unit circle, 2 pi plus pi by 2, so 5 pi by 2. If I continue same way, one revolution plus half revolution, so 3 pi. Now arc length become 3 pi. Why 3 pi? One revolution is 2 pi and then half revolution. Then next, here, this arc length is pi by 2, so 3 pi plus pi by 2, so it becomes 7 pi by 2. And now if I complete 2 revolution, this is 4 pi. Okay, one revolution 2 pi, second revolution rotation 4 pi. If I take third revolution, this becomes 6 pi. If you move in which direction? Anti-clockwise direction. Now if I go in clockwise direction, I'll start in this way. If I start from this, here arc length is 0. Up to this arc length is, this arc length is pi by 2, because this is pi. But you are moving in clockwise direction, so we put the minus sign. So this become x equals to minus pi by 2. So minus pi by 2, 3 pi by 2, 7 pi by 2, all are point B dash, remember. Same way if I continue here, this arc length is pi, but if I am moving in clockwise direction, so this become minus pi. Minus sign indicates that you are moving in clockwise. If I continue in this direction, this become minus 3 pi by 2. If I complete one rotation, this become minus 2 pi. So all these are the points on the unit circle. 0, 2 pi, 4 pi, minus 2 pi, 6 pi, all are A. Pi by 2, 5 pi by 2, minus 5 pi by 2, all are nothing but the point B on the unit circle. Here at this place, you have pi, 3 pi, minus pi, 5 pi and so on. This is point A dash, which has minus 1 comma 0 coordinates. Here we have, minus pi by 2, 3 pi by 2, 7 pi by 2, all are nothing but the point B dash. So this way we have the concept of the unit circle and trigonometric functions. Remember, the mainly trigonometric functions, cos represent x coordinate and sine represent the y coordinate of every point on the unit circle. Remember, why I wrote x here? Because I have considered this arc length as x. So here cos x, here sine x. Okay, now further let's see with the help of unit circle. Again, I'll draw the unit circle here and you will see. So then here the next page, if I see this, again I'll start with the unit circle. I want to just get into some values of some standard arc length. This is the unit circle. Now you know. Here you know coordinates 1, 0. This is A. You know coordinates 0, 1. Here you know A dash minus 1, 0. You know this because this is 1 unit, this is 1 unit, this is 1 unit. If I call this as B dash 0, minus 1. Okay. Now what is, if I start from this, what is the arc length here? X equals to 0, you know. So this one basically here, first coordinate, that is nothing but, first coordinate is nothing but the cosine x. But what is x here? That is 0. So cos 0 is 1, you know from 10th standard. This represent which function? Sine function. What is the arc length here? 0. So I'm just putting in this only, remember. Here I'm putting 0. So sine 0, but here it will be 0. So this is second coordinate. So this is sine. What is the arc length here? 0. So sine 0 becomes 0, which also you know from 10th standard. Now come to this. What happens here? Arc length become pi by 2. So here x is pi by 2. Remember, x is pi by 2. So this represent which coordinate? Cos function. The first coordinate represent which function? Cosine function. So we write cos. Here, what is this arc length? That is pi by 2. So instead of x, I am writing pi by 2. So what is cos pi by 2? Which is 0. You know, pi by 2 is same as 90 degree. This much you know. Pi by 2 is same as 90 degree. We did. So these also you know from 10th standard, cos 90 is 0. Come to this. This is a second coordinate. So it's a sine function. So sine here. Arc length, which arc length here? Pi by 2. So sine pi by 2. Sine function represent which coordinate? Second coordinate. So sine pi by 2 is 1. You know sine pi by 2 is same as 90 degree. You know sine 90 is 1. So we have this. Okay. Now continue with this. If I move in this direction here, this arc length is pi. So this first coordinate, that is minus 1, which is the value of cos x. What is x here? You know it is pi. So this is cos pi. Cos 180 degree, which probably you have not studied in 10th standard. Cos 180 degree. This is minus 1. Then sine, second coordinate, which is again pi. Sine pi, which is nothing but 0 here. Remember, second coordinate. Come to this now. If I move in this direction, this arc length you know 3 pi by 2. Why 3 pi by 2? This is pi, this is pi by 2. So pi plus pi by 2, it is 3 pi by 2. Pi plus this much arc length is pi, this is pi by 2. So total become how much? 3 pi by 2. This is first coordinate which represent cos function. So cosine 3 pi by 2. Here x is 3 pi by 2, which is how much? 0. What about this? Here, this is the second coordinate, means sine function. What is the arc length here? 3 pi by 2. So 3 pi by 2, which became minus 1. Now I'll complete one rotation. I'm here again, so 2 pi. So arc length is now 2 pi. This represent cos function, which is 1. So I can say that the cos 2 pi, arc length is 2 pi, which is 1. This second coordinate is given by sine function. So sine 2 pi becomes 0. Remember, Sine 0 is 0, sine 2 pi is also 0. See, sine 0 is 0, sine 2 pi is also 0. Cos 0 is 1, cos 2 pi is also 1. Now, if I take again one more rotation in this, and if I take 4 pi here, so you can write directly sine, so let me write here sine 4 pi. So sine 4 pi means which coordinate? Second coordinate, which is 0. If I write cosine 4 pi, cos means which coordinate? First coordinate, which is 1. Right? Now, if I take one more rotation, for example, so suppose I'll get the 6 pi here. After how many rotations? 3 rotations. In which direction? Anti-clockwise direction. So cosine, now here if I write 6 pi, cos 6 pi, cos means 6 pi is here, then the first coordinate is 1, so cos 6 pi is 1. What is sine 6 pi? It is 0. Now you can answer such simple questions. For example, what is cosine 3 pi? Suppose I want to answer this. What is cos 3 pi? So what you have to do, you need to ask yourself where is 3 pi on the unit circle. If I take one rotation, 2 pi, and then half rotation, 3 pi is here, you know. Arc length. Now cos represent which function? First function, that is the first coordinate, so minus 1. Right. If I ask you what is sine 3 pi, so you ask yourself where is 3 pi on the unit circle? So it is here, because if I take one rotation it is 2 pi, then half rotation pi, so it is here, so this becomes 0. Suppose I want to answer sine 100 pi. Now the question is, where is arc length 100 pi on the unit circle? That's my question. Now 100 pi means double of 50 pi. One rotation means pi, 2 pi. Second rotation means 4 pi. Third rotation means 6 pi. So how many rotations? 50 rotations. In which direction? Anti-clockwise direction. And you will reach here only. Sine represent which coordinate? Second coordinate. So sine 100 pi is 0. What is cos 100 pi? So where is 100 pi on the unit circle? Here only. Cos represent first coordinate. So this way you can answer such values. Now, next, suppose I want cosine minus pi by 2. This one. The next point, this one. Now, question is, where is minus pi by 2? Minus sign indicates that you are going in which direction? Clockwise. So I'm starting from here, I'll be here. You know that this is minus pi by 2. Right? X. Now, cos function represent which coordinate? First coordinate, so cos minus pi by 2 is 0. What is sine minus pi by 2? Sine represent which coordinate? Second coordinate, so here minus 1. So cos 3 pi by 2, 0, 0. Same as minus pi by 2. Sine 3 pi by 2 minus 1. Sine minus pi by 2 is also minus 1. It has repeated values, remember. After one rotation, values being repeated. So later on, we'll see that these are called periodic functions. After certain interval, values being repeated. So these are known as, all trigonometric functions are called periodic functions. After certain interval, values being repeated. Okay. Suppose next I want to answer cos minus pi. Now you must have realized after taking so many examples, the question is, where is minus pi on the unit circle? Minus sign indicates you are going in clockwise direction. So I'm starting from here, we move in this direction. So minus pi. Now cos minus pi means first coordinate, so it is minus 1. Sine minus pi, this coordinate, so it will be 0. Okay. Suppose next I want one more. Let me write cos minus 3 pi by 2. Where is minus 3 pi by 2? On the unit circle, you start from here and you reach here. So this is minus 3 pi by 2. First coordinate is 0. So cos minus 3 pi by 2. What is sine minus 3 pi by 2? It would be second coordinate here. So it will be 1. So this is 1. So this way we get the values of sine and cosine from the unit circle. These 4 points are very important: A dash, B dash. So keep this unit circle in your mind. You can answer some standard values very easily. Even this is very important in physics also. Okay. Now one thing you must have noticed for cos and sine function, cos means first coordinate. You see this is 1, 0, -1 and 0. So first coordinate is maximum 1, minimum -1. The values are always from -1 to 1. Of which function? Cos function. Second coordinate minimum -1, 0, 1, 0. That means sine function takes the value from -1 to 1. So this I'll write as range of these two functions. So I want to write, you have studied range of linear functions and so on in that function chapter. Now here I'll write range of cos and sine functions. Sine functions. Range of cos and sine functions. Okay. Range means what? Maximum and a minimum value for sine as well as cosine. So you know from the unit circle, for every x, this is read as for every. How do we read? For every. This is read as for every. For every x, arc length x, cos x maximum is 1. It never go beyond 1 and it is always greater than or equal to -1. So values is always from -1 to 1. So therefore we say that the range is closed interval -1 to 1. Of which function? Cos function. And same thing will happen for sine function also. You have already noticed that the cos function is nothing but which coordinate? First coordinate on the unit circle. Now the maximum value of the first coordinate is 1 and minimum value of the first coordinate is -1. That you know. Okay, so range is -1 to 1. And for every x again, for every x, sin x is always less than or equal to 1 and greater than or equal to -1. So therefore we say that range of sine function is also closed interval -1 to 1. Okay. So we write here range of, if I write here range of cos and sine functions, both the functions, equals to close interval -1 to 1. Range of cos function and sine function, that is close interval -1 to 1. You find, use scientific calculator, you find cos of anything. Cos, if I write even any value here, for example, if I write 201 pi, you will notice that this value always from -1 to 1. It can be 1, it can be -1, but it never go beyond this interval. It would be always, if this is -1 and this is 1, it would be always in this portion, remember. Range of cos and sine function, that is closed interval -1 to 1, remember. That's one important part which is obvious from the unit circle. Okay. Now next point I want to write before I get into definitions of the other trigonometric functions, which are called zeros. Zeros of, let's write sine function, sine x and cos x. Zeros. Now zeros means what? We find, zeros means this, we find all x, you know these arc lengths are called angles, all x such that, let me write first, for example, sine x becomes 0. These are called zeros. Zeros means roots basically, you know. What, for example, if I ask you this simple question, what are the zeros of this equation? X square minus 1 equals to 0. What are the zeros of this equation? So you can answer very easily, that is x equals to plus or minus 1. Zeros means what? Values of x for which this equation becomes 0. These are called zeros. So here same question but for trigonometric functions. What are the zeros of sine function? We find all angles x which are called arc length for which sine function becomes 0. Now sine function represent which coordinate? Whenever you talk about sine and cosine, you need to go to unit circle. Now on the unit circle, sine function represent which coordinate? Y coordinate. So you just check on the unit circle where y coordinate becomes 0. Sine is 0 means y coordinate is 0. Y coordinate is 0. Y coordinate equals to 0. You get all x for which y coordinate is 0. So let us have a look on the unit circle. See here y coordinate is 0. What is the arc length here? 0. So I'll write x equals to 0. Continue now. Here y coordinate is 1. Here y coordinate is 0. What is the arc length here? Pi. So I'll write here pi. Then continue. What is the arc length here? What is y coordinate here? -1. Continue here. Now arc length become 2 pi. So I'll write here 2 pi. Continue further. Y coordinate 1. Here y coordinate is 0. What is the arc length here? 3 pi. Continue further. Again 4 pi. Sine 4 pi will be 0. Y coordinate is 0. So 4 pi. And so on. Even if you move in clockwise direction, here, if I start from this, here x is 0. What is x here? You can write minus pi. So you can say that the sine minus pi is 0. We already written somewhere, you see here. Sine minus pi is 0. So minus pi also you can write at this place. Now continue further. If I go this, here y coordinate is 1. Here y coordinate is 0. You can write x equals to minus 2 pi after finishing one rotation in clockwise direction. So minus 2 pi. Same way you can continue minus 3 pi, minus 4 pi and so on. So what is this? These are the values of angle x, which we call as arc length also. Angle x for which sine function becomes 0. So in general I can write like this: x equals to n pi, multiple of pi, where n belongs to z. So this is the next important point which we need to remember. N pi, remember, small n, where n comes from z, right? So I can write here sine x equals to 0 if and only if, double implication, what is the x? X is n pi, right, where n belongs to z. What do we understand by this? This means if I take n equals to 0, for example, so x is 0, if I put 0 here, its value is 0. If I take 1 here, that x will be pi, so sine pi will be 0. If I take 2 here, this is 2 pi, sine 2 pi is 0. So these are called zeros of sine function. So if you want, you can write like this: set of zeros of sine function equals to x equals to n pi such that n belongs to z. Clear? I hope this is clear to you. All values of x which I place in the sine function, it becomes 0, remember. So now you can answer immediately. What is sine 2000 pi? Tell me. It has to be 0. What I did, I've chosen n equals to 2000, and if you have any multiple of pi, sine function becomes 0. You can think that way also. 2000 pi means 1000 rotation. 2000 pi means you take how many rotations? 1000 rotation in which direction? Clockwise to anti-clockwise direction. So you'll get this point only. Here only you have 2000 pi. And what's the second coordinate? You know here second coordinate is 0. So sine 2000 pi has to be 0. If I ask you what is sine minus 100 pi, so I've chosen n equals to minus 100. So sine has to be 0. Right? That way we can answer. Okay. Now next we go to cosine function. Zeros of cos function. Cos function. So what is the question? Zeros, you know, as I explained, we find x such that all x, remember, such that cos x equals to 0. We find all x for which cos x becomes 0. Okay, so now here you again need to go back to unit circle. Cos x is 0. Now cos represent which coordinate? First coordinate. So I'll draw unit circle here. Okay, you know that this is 1 0, you know that this is 0 1, you know that this is minus 1 0, you know that this is 0 minus 1. First coordinates should be 0. I'll start from here. Let me take the same unit circle which I've used earlier. Let me see this. I'll start from here. See, first coordinate is 0. What is arc length or angle here? This arc length, you know, pi by 2. So here first value is x equals to pi by 2. Fine. Okay. Continue further. Here first coordinate is minus 1. Here first coordinate is 0. What is arc length here? You know that it is 3 pi by 2. So second value is 3 pi by 2. Continue further. Here first coordinate is 0. Here first coordinate is pi by 2. If you remember, after one rotation this becomes 5 pi by 2. You know it. After the one rotation it becomes 5 pi by 2. You know very well. Okay. So here first coordinate is 0, arc length is pi by 2. So here you have pi by 2. 5 pi by 2. Further if you continue, you know that here it becomes 7 pi by 2. After one rotation, remember. So this is nothing but x equals to here 7 pi by 2. 7 pi by 2 means this point. Here first coordinate is 0. Now if you move in clockwise direction, if I start from here, you know minus pi by 2. So this is minus pi by 2. Continue in the same direction. You know that this point is minus 3 pi by 2. So this is minus 3 pi by 2. And so on. So what we notice after writing so many values, these are the values of angle x or arc length x, such that cos becomes 0, cos pi by 2 is 0, cos 3 pi by 2 is 0, cos 5 pi by 2 is 0, cos 7 pi by 2 is 0. In general, you can write x equals to, see everywhere you have pi by 2, remember. So pi by 2 is there. Now this is 1, 3, 5, 7. These are nothing but odd numbers. So you can write 2n. You can write here 2n minus 1 or 2n plus 1, whatever you want to write. 2n plus 1. Or आप ये भी लिख सकते हैं, both are correct. 2n minus 1. Both are fine, remember. N belongs to z. Here n belongs to z. All integers. This is the general set of zeros. What was the set of zeros for sine function? It was n pi. What's the zeros of the cosine function? 2n plus 1 pi by 2. That is odd multiple of pi by 2. Remember, this is called odd multiple. So zeros of cos function equals to 2n plus 1 pi by 2. Both of this can be used freely, remember. Both are having the same meaning, such that n belongs to z. Again repeat, these are the zeros means if you put this value in the cos function, it becomes 0, remember. See, if I put here, if you want to verify, you put n equals to 0, you'll get pi by 2. Put n equals to 1, so 2 plus 1, 3 pi by 2. Put n equals to 2, 2 into 2, 4 plus 1, 5 pi by 2. Put n equals to, for example, minus 1. If I put minus 1, minus 2 plus 1, which is minus pi by 2, and so on. So this describes all these values. So we did 4 things, remember. One is range of sine and cosine functions. So let's recap. What's the range of sine and cosine function? Closed interval minus 1 to 1. Maximum value is 1, minimum is minus 1. Range of both of this function, number 1. 2 things and 2 more things, that is zeros of sine function. What's the zeros of sine function? N pi. What's the zeros of cosine function? 2n plus 1 pi by 2. So after knowing this, we now define the other trigonometric functions. So I'll prepare a table here. With the help of table, I'm writing remaining functions. Okay. So no problem. Let me write directly. Next one is tan function, for example. So tan, you know definition. It's a function from I'll write domain and codomain. You know tan x is ratio of sine x upon cos x. That much you know. Now you know when you have studied division of two functions f by g, if you remember, when you write this, if you remember domain, you need to drop all values from the domain for which gx becomes 0, if you recall. So here domain will be, codomain will be r, of course. Now for what values of x cos becomes 0? You know this, cos x equals to 0 implies what is x? That is 2n plus 1 pi by 2. We did it right now, zeros of cos function. So here from r we are going to drop 2n plus 1 pi by 2. You can take every real number but not this. This is a domain of tan function. This is a domain of which function? Tan function. Why we drop this from all real numbers? Because if you choose this value, then this becomes 0 and something upon 0 is not defined. For example, can we find tan pi by 2 here? No. See, pi by 2 I have eliminated, but if I take pi by 2, what is tan pi by 2? You know from 10th standard, sine pi by 2 upon cos pi by 2. You know sine pi by 2 is 1, which is sine 90 degree, which is 1. And what is cos 90 degree? It is 0. You know that this is not defined. Something upon 0 is not defined, you know. So that's why pi by 2, 3 pi by 2, 5 pi by 2, all we have eliminated from the domain. You just need to recall f by g from the functions chapter. You just recall this, you will realize further. When we do f by g from the domain of function f by g, you need to drop all values of x for which gx becomes 0, if you remember. So the same concept are used. I have dropped all x from r for which cos x becomes 0. Codomain remains same r. Now without proof we write this. I'll write without proof. Range of tan function is all real numbers. This I'm writing without proof. Just accept it. Range of tan function is all real numbers r. Tan function can be 200, remember. For example, this is possible. Tan x equals to 200 is possible, remember. Tan x equals to 10,000 is possible, remember. Right? But sin x equals to 1.1 is not even possible, because maximum value of sine function is 1, remember. Okay. So range of tan is r. Now we go to cot function. Cot is a function from something to r. Codomain will be r. What's the definition of cot x? That you know, it is cos x upon sin x. Now again, this is a division of the two functions. Which function in the denominator? Sine function. So from the real numbers, you need to drop all x for which sin x becomes 0. Now again recall, sin x equals to 0 implies what is x? N pi. You know zeros of the sine function, so I'll drop n pi from this, minus n pi where n belongs to z. This is a domain of cot function and codomain is r. I again repeat, you must understand why I wrote r minus n pi. Why I did? You go back again, function chapter, you go back to f by g. If you recall any example of f by g, when we wrote the domain of this, we have written in such a way that you drop all values of x for which denominator becomes 0. Now what are the values of x for which sin x becomes 0? That is n pi. So from r we drop n pi, remember. For example, this is not defined. You cannot find cot 0. This is not possible. Why? Because this is cos 0 upon sine 0. Cos 0, you know 1. What is sine 0? 0, undefined. This is not defined, undefined. That's why we eliminated all these values, remember, here. So you cannot take cot 0, you cannot take cot pi, and so on, remember. Right? Okay. So this is a cot function. So tan is a function from this to this. I hope this must be clear to you why I have eliminated sin x upon cos x, which you know. Range I wrote without proof, all real numbers. Cot function r minus n pi. Why I have written minus n pi, you know. And range is the same as cot function. Again, I'll write without proof. Range of cot is all real numbers r. Okay, next we go to definition of, now fifth one, definition of cosec function. Now you can answer it. Cosec function. Now you know that the cosec is just the reciprocal of sine, so it is just 1 upon sine x, that we know. Cosec is a reciprocal of sine, and codomain would be r again here, which is denominator function here, sine. So from r, what I am going to drop? All x for which sin x becomes 0. You recall sin x is 0 implies x equals to n pi only. N pi, you know this. So I'll drop n pi from this. I hope now this is clear to you, where n belongs to z. N pi. R minus n pi to this. Okay. And here range would be range of cosec function. It is a reciprocal of sine function, remember. So it's a complement of range of the sine function. What's the range of sine function? Close interval minus 1 to 1. Now other than this portion, so range will be from this to infinity and from minus 1 to minus infinity. You cut this portion. Which portion? This portion, remember. So range would be range of cosec function. I can write in this way. Minus infinity to minus 1. Minus 1 is included, remember. Union starting from here. 1 to infinity. Now this you can write as all real numbers other than this portion, which is open interval minus 1 to 1. Remember. You drop just this open interval minus 1 to 1, remember. This is the range. For any x, arc length x, for any x, cosec function, cosec x will be 1 or more than 1, that is greater than or equal to 1, or minus 1 or less than minus 1, that is cosec x is less than or equal to minus 1. Even it never be 0, you know, somewhere you have 0. You cannot get any x for which cosec becomes 0, right? If cosec is 0, then sine becomes infinity, which is not possible. That's why. So for any arc length x or for any angle x, value of the cosec function is 1 or more than 1. Value can be 1. You try to find x for which this become 1. For example, you take pi by 2, you know this. Cosec pi by 2, 90 degree, which is 1 upon sine pi by 2. Sine pi by 2, you know 1. So this is 1. So cosec pi by 2 is 1. So value can be 1, but not less than minus 1. So 1 or more than 1. Here minus 1 or minus 1 or less than minus 1. So are all real numbers, but other than open interval minus 1 to 1. It can be 1, it can be minus 1. More than 1, less than minus 1. So this is always true for cosec function. Range is r minus open interval minus 1 to 1. It is same as this. I repeat, range of cosec function is r minus open interval minus 1 to 1. Same way we define next sec function. So next let's see sec function. If I define here, let's see sec. It's a function from here, codomain is R. What's the definition of sec x? You know it is 1 upon cosine x. So what should be the domain here? Now you can answer this. R minus all x for which cos x becomes 0. This just I'm reminding you every time. What are the values of x for which cos x becomes 0? Odd multiple of pi by 2. 2n plus 1 pi by 2 where n belongs to z. So here r minus 2n plus 1 pi by 2 where n belongs to z. 2r. Remember, this is the domain of sec function. Sec x is 1 upon cos. That's the reciprocal of cos function. Okay. Now this is very clear too, so I'm not emphasizing much on it. Next question is what's the range? So same concept, range, as I explained in cosec function. This is minus 1, 1. This 0. This is the range of which function? Cos function. Close interval minus 1 to 1. This is a reciprocal of this. So either it will be this portion or it would be this portion, remember. So for every x, again I'm telling you, this is read as for every. This is read as for every x. How do we read? For every x. Because sec x is 1 or more than 1. So greater than or equal to 1 or